This is Introduction to Functional Reactive Programming. So a little bit about me. My name is Eliasz Sawicki and I am iOS developer. I run my blog at eliaszsawicki.com, so if you're interested, visit it there. Also, the slides from this presentation are already present in my slides section of the blog, so you can check them. So, I live in Gdańsk. I work at Bright Inventions. We create mobile applications and services around them. And for about 2 years now, I've been using Functional Reactive Programming framework to build those applications. And I feel that it's pretty cool, and I wanted to share it with you, and I wanted to show you how to use those. So today we'll be talking first about what is Functional Reactive Programming and how to work with streams, which are basically representation of asynchronous data in our application. And later I will get to ReactiveSwift part, and many of you can ask simply, why should I listen about ReactiveSwift? I've never touched Swift before, or iOS platform is foreign for me. I prefer Java. And my answer for that is that Functional Reactive Programming frameworks is basically like you learn how to drive a car, right? And when you learn it once, then you're pretty fluent in that. And if you go to your friend's car, there may be more gears in the car, or the steering wheel may be a little bit more sensitive, but the general idea is basically the same. So who was on RX Java talk today? Yeah, so I tried to make those concepts much easier and to grasp the whole idea. So even if you do not work on iOS, you'll probably be able to use those concepts in your day-to-day work. So, if you do not know anything about the topic, the first thing that you probably do, and this is what I do, is I go to google.com and I type in phrase, hoping that the explanation of that will be at least satisfying for me. And if you do that, you come to Wikipedia page, and the first thing you can read is that Functional Reactive Programming is programming paradigm for reactive programming, using the building blocks of functional programming. And what I would normally do now is to say that, oh, those definitions always hilarious. But at this point, I may say that this is not too deep definition of the concept, but it basically grasps the idea of what you will do using those. So we will work with asynchronous data flows in our applications, and we will use available blocks like map, reduce, filter, available from functional programming. So let's get to the first part of the definition. So what is reactive programming? And reactive programming is not a mathematical concept. It's basically reacting to state changes and working with asynchronous data flow in your application. And any flow of data in your application can be explained, modeled using those streams of values. And a great example of that is, who of you worked with Excel before? I did, yeah, many of us. So there is a great thing in Excel that you can do, is you can write equations in certain cells. So let's imagine we have like 3 cells available, cell A, B, and C, and we type equation B plus C to the A cell. And what will happen now if any of the cells B or C changes? Who knows? Yeah, so it's every time something changes in those cells, the cell A will change as well. And that is what we want to achieve writing our applications. We want to define those equations and make our state of application change on its own. And on the other hand, there is this functional programming concept, which is a pretty deep topic, and I think that this talk is not enough for that. But what we're interested here especially are those blocks that are available in functional programming. For example, map, reduce, or filter. Who of you, again, worked with those before? Great, great. Okay, so talking about functional programming and about functional reactive programming, you may often hear that it is declarative. But what declarative programming means? And there are two kinds of programming. The first is called imperative programming. And on the other hand, you have this declarative programming. And what's the difference between them? So when talking about imperative code, let's take it like having a receipt for a cake. So you've got specific steps presented for you that specify how to get to the result that you want to achieve. And that's basically how imperative programming works. It's like take 4 eggs, put some milk, put some water, put it to oven, stir everything, and that covers the result that you want. And when thinking in code, let's imagine we have an array and we only want to take even numbers out of that. So here we just have an array, we have an empty array of even numbers, and what we do is, okay, let's go through each element. If element is even, then basically append it to existing array of even numbers. And I think that many of us wrote this kind of code before, and it's not like it's not readable, it's pretty much okay, but you can do it another way. And here comes the declarative way of programming. So it's basically like having a great chef that does not need a receipt for a cake. What he needs is, he needs a photo of the cake that you would like to eat. And he's so good that he knows how to achieve this. So you specify the result, you do not specify the steps. And here comes the way of how you would represent this code in declarative way. So it's much shorter, you specify the result here, so you're interested in only in even numbers, and your chef is here. And this way you'll be able to write much shorter code that is pretty much more readable, in my opinion, and it's pretty fun to work with, actually. So when talking about reactive programming or functional reactive programming, we'll be usually talking about working with those asynchronous data flow and streams. And what is a stream exactly? So stream is a definition of values flowing through the... Okay, sorry, I'm too loud, I guess. Okay, so this is definition of values flowing over time. And this x-axis here stands for time in our application or in our system. And this vertical line here stands for a signal that has completed, it has ended. So whenever you model any behavior in your application, you can model it using streams. So those values could be like GPS updates in your application, or it could stand for values that come from HTTP requests. So it's basically what you can model that, you can model anything using that. And the great part of working with streams comes actually from manipulating them. So if you learn how to tame the streams, to make them give you values that you actually want, you receive great results. So let's take a look at a few of those transformations that you can use here. So the first one is called the map. Anyone met map before? I did. Yeah, great. So what map does is by putting map operation on this first stream, it creates another stream, so it does not harm any values there. And the second stream will now propagate values that are changed, and this change is specified in map function. So in this case, every number will be basically manipulated, multiplied by 10. So if I start observing the second stream, I will get values like 10, 20, or 30 in this case. There will be multiplied by 10. So on the other hand, we have this filter function that we have seen before in array. And what it does is we specify what values we are actually interested in. Sorry, do I need a microphone? Or? Yeah. Okay. So, in this filter operation, we specify the result that we actually want to get on this second stream. And in this case, we say, okay, so if value comes that is greater than 10, let's propagate it on the second signal. If it does not match this equation, just leave it. I don't care about that. And still, we do not change values from the first signal. So you won't damage any values that come to other subscribers. And there is also this third operation that is a bit different than those. So you can see that those values are not propagated immediately on the second signal. And what actually happens is every time value comes, it goes through this reduce function, which in this case is basically sum of those values. And at the time that first signal completes, it will be propagated on created signal. And that's why it's different than the previous manipulation. And working with single manipulations is great, and you can do magic with that. But even more greatness comes from working with multiple streams. And this, especially in iOS world, for me, there's always this pain because you can model behaviors using many patterns that are widely used. So, for example, you can use a delegate pattern for something. You can use key value observing or notification center. And when you use all of those, the problem is that you can't actually easily combine them. And if you model things using streams, it's pretty easy to get those. So let's take a look at this combine latest method. What it does here, it takes two signals, but it can take even more. And you have to remember about a certain thing, that this created signal will not propagate any value if each of those upper signals do not send at least one. And at the time that, so if first signal emits value number 1, nothing is propagated yet, but then we'll receive 1A, 2A, 2B, 2C, 2D. So if anything comes from any of those signals, we will receive an update with all of those values, both values from latest values from each signal. And there's also a basic merge. That's what it does. It's if you have two streams of the same type of objects, then it creates a stream that will propagate all of them. And having those manipulations is pretty cool, but what's even better is the fact that you can change them. So you can first specify that, okay, give me that stream, but I only want values that are greater than 10. Then I actually do not need that type, so map that to a string and then combine it with another signal. So you can really model things the way you really like and you want to achieve those. And more graphs like this are available on ericsmarbles.com. So if you are new to functional reactive programming or you want to learn how those functions work, you can go there and you can check this out. There are even more. And now the fun begins because we are getting to ReactiveSwift part. And many of you can ask, why is it ReactiveSwift? Rx implementation is also available on iOS platform. Why shouldn't I use that? And I think that Reactive Cocoa has many benefits that actually help us understand how the stream work and how to use them. So, in order to start using Reactive Cocoa or any functional reactive programming framework, is to start thinking in signals, in streams. And this is what we actually want to do, because the mindset, how we write our applications, will have to change, because we'll abandon our old patterns, and we'll use Reactive Cocoa in this case for our further work. But in order to understand how they work and in order to think in signals, we have to know what a signal is, actually. So let's take it like that. Let's imagine that this screen here is a signal. So from the time that you actually came here and just a little bit longer, it still propagates some values. It gives you a new slides, and you can observe this and you can react to any changes. So the first job of a signal, of a single stream, is it represents events over time. And what actually happens is that if you just observe this screen, nothing really happens. So if any new observer comes and just stares at the screen all the time, no side effects are performed here. And you cannot actually access those values randomly. So the time aspect is really crucial in programming with streams. So you can't basically come and tell this screen to show you the last slide, so maybe you can decide to just leave this place. No, you have to take them all. And if you cannot basically access those values randomly, how do you do that, right? And you have to observe them. So it's basically the same like looking at the screen and taking the slides and thinking about them, just, oh, maybe that's useful. So if you observe those values, if you observe the stream, you will get notified about each value. And what happens if you do not observe the stream? Someone? Yeah, actually, if you do not observe the stream, you lose the values. So if you took a nap like 10 minutes ago, you probably do not know what were the slides before, and that's the same how signal works. If you do not observe it, the values are basically gone for you, and you can't reach them right away. So observing a signal in order to get those values is pretty crucial here. And that's why it's also called a push-based stream, because it does not care whether anybody observes that. It only cares if somebody pushes values to the stream so that someone maybe is interested or maybe he's not. And I'm talking about all those values that flow through the signal, and what is actually a value. So in case of reactive Cocoa, they are called events. And events are basically a formal representation that something happened somewhere in your application. And let's take a look at this. This is a structure called idea. It has a content. It also has a quality. The quality can be even either great, average, or worse. And actually, from the beginning of this talk, with each slide, you've been receiving this kind of idea. And you may see that nothing really changed. You took those ideas, you can think about them, you can note them down, but it did not harm this signal here, the stream. But on the other hand, we have the second kind of signals, of streams, of events, sorry, that are called terminating events. And these are these are much more harmful, and this could be either completed event that tells us that the stream succeeded with its work, and then the stream's signal's lifetime is basically over. We have also a failed event that tells that something did not go right, and it probably holds an error type for us. And in Reactive Cocoa, there is also a third event called interrupted, which I usually use when, for example, user presses a cancel button, and that's not exactly a failure, that's not a success, it just tells that something was not exactly right. And we will model our behaviors in applications using those. So let's take a look at this presentation signal that I was talking about. So this is a signal that will emit idea values and will not end up with an error. And when we call a pipe method, we receive two things. The first thing is a presentation signal itself. So if you want to get those values, you basically observe that and you will be able to react to that. And on the other hand, we have this presentation observer. And whenever you want your signal to emit a value, you have to push it here. So you call presentation observer.send value idea or send completed. And if you call that, then the signal will propagate the value or the event. So in order to observe those values, you basically take a signal and you call .observe values, and then you will get a closure. You can assign a closure that will invoke behavior that you want. So in this case, every time I receive an idea from a stream, I can remember that. Or if completed event comes, I can say, okay, time for a break. That's on my side. And I was talking about those manipulations and those operations that you can put on signals. So let's take a look at that. And for example here, I only want to get the great ideas, because why should I bother about the rest? So I put a filter on this presentation saying, okay, so I want idea to be a great quality. And now I have this new signal. We do not change the first signal. We basically create a new signal, and if I observe this signal, I will only get ideas of great quality. That's what basically happens. And if someone pushes idea structure to this base presentation signal, if it matches this pattern, it will be also propagated here. And I can say that, okay, I'm a positive listener, so here this guy's intentions are pretty cool, so let's map the quality of each idea to a great one. And still, I do not change values on the base signal. I create a new signal that will only emit values, but each value's quality will be great. And on RX Java, you may have heard there is an observable type in this implementation, and it stands for there are actually two kinds of streams. And I think that Reactive Cocoa is at this place a little bit better because we have actually two different representations of a stream. So we have a signal and we have a signal producer. And in RX implementations, these are represented by observable pattern. In RX first version, from what I know, the second one will change that. So what is a signal producer? So in case of playing signal stream, I said that it was this screen here. In case of signal producer, that's basically me, thank you. And what it actually does, it represents a work to be performed. So with a base signal, we could say that it could represent touches on a screen. So it could go for a whole lifetime of our application. And whenever somebody wanted to work with a stream, he did not trigger any side effects. And in case of a signal producer, if you want to work with a signal producer, you create side effects. So in this case, if anybody asks for a presentation, a new presentation will be created. And it can be explained easily by, for example, HTTP request. Every time we want to perform a request, we want to receive new data. We want to tell our little guy that, okay, go to a server and bring me the data. And if it was represented by a pure signal, then probably this would not cause the side effect of going through the web. And in this case, every time you start working with this producer that goes to the server, he will go again and again. And that's the basic difference, whether the side effects are performed or not. And yeah, so these are the side effects. And if you do not ask a producer to do its work, nothing will actually happen. So it's a great way maybe to save your resources because you will not waste them if nobody's interested in your work, for example. And let's take a look at this RunPresentation method. So this method, what it does, it actually returns a signal producer that when you want to work with him, he will give you idea values and will not end with an error. And here we have this return statement. So it says, okay, return signal producer, and he will perform this kind of work. So if anybody is interested in values, he will just push idea values to its observer, and then he will complete. So if you want to work with him, you do something like this. You call RunPresentation, and what's important, nothing happens yet. If you call RunPresentation, what happens is you get this producer. In order to tell him that you want to get this work done, you have to call start with values. And then you will have access to values that come from the producer. Or you can say, okay, start with a signal. And then you receive a signal that you can subscribe to many different events of that work. And what's important here, that every time I call start with values or start with signal, this job will be performed again and again. And when we did that with a basic signal, when we called observe values, nothing really happened. We just got the same values that anybody did. And in this case, these could be very different values. And that's the basic difference between cold signals, cold streams, and hot streams. And if there was only one thing that I wanted you to remember after this presentation, is to remember about this difference, to know when the work is performed. In observable case, you have to just think maybe from a concept. So maybe if I get observable for a screen, that will not perform any work. If I got it for an HTTP request, yeah, maybe if the guy wanted to implement it like that, maybe it's like that. And here in Reactive Cocoa, we have this, we know which one is which. And this called stream will be our signal producer. It's called because it has time to rest. It does not work all the time. He only works when we ask him for. And on the other hand, we have this hot signal that no matter what, no matter if you observe it or not, he will still propagate those values. So let's get to another mechanisms that are available in Reactive Cocoa. Next one is called a property, and property is basically a container for our variables, and each time that it changes, he will, if we are interested, it will let us know about the change. So in this case, we have a slide mutable property that stores slide values, and at the beginning we assign a first slide here, and we also start with values on this slide property. And when, every time somebody calls, for example, slide.value equals slide number 2, this block will be invoked, and this operation will be performed by our application. And having properties and having streams of values allow us to create great bindings in our application. And in case of iOS application, this is pretty cool because you can actually map values, map streams to certain controls in on your screen. So in this example, this is a slide number property which stores integer values, and it tells us what slide number it actually is. And we have a signal that emits slide objects. And we cannot exactly right now bind it to this property because there is a mismatch in a type. But what we can do is we can actually map this signal and tell, okay, this slide type does not fit here, but take the slide number and put it into this property every time a value is propagated. And many UI controls from iOS have they have these extensions that give a property to those standard controls. So you can, for example, say label.reactive.text and bind this signal here, and every time a value is propagated, your UI will update, and this label will show a new content for you. There are two mechanisms left that I wanted to tell about. The first one is called a scheduler. So you can basically tell your producer to start its work within like 2 hours if you're not interested right now, or do stuff like this. But the thing that I pretty much care about most is telling where to perform its job. So sometimes we want our work to be performed on a specific thread or a queue. In this case, if you want to update UI in your iOS applications, you have to do that on the main thread, on the main queue. And that's what you specify by telling, okay, observe it on a queuescheduler.main. And then basically every closure, every update here will be performed on the main queue. And the last but not least, memory management. And who likes memory management here? Everybody. And that's pretty painful when you start working with functional reactive programming frameworks, because you have to remember about these mechanisms that they give you. And these are called disposables. And in order to explain disposables, I would say that at the time you entered this room, I gave you a ticket. And that's a sign for me that you are still interested in my values, in the values that this signal will propagate. So even if you leave the room, I will send you a push notification to your mobile phone so you don't miss that. And if you do not want them, you simply take this disposable and throw it away. And that's basically what happens with Observer. If you start observing for values, you receive a ticket. And if you're not interested and you do not want to invoke this closure here, you say, okay, just put it away, dispose it, and you know that this won't be invoked again. Or if you work with a producer, that's even better, because if producer knows that nobody is interested in his work, then he can say, okay, let's free the resources, nobody is interested in those values, so I shouldn't propagate them. And that's why you should use disposables, and you should care about the memory that you take, basically, by using those. And let's end up with an example app that I wanted to show you. So what it basically does, this is an application that contains a form, And if you fill each of them correctly, then the save button is enabled, and the user can basically process to another screen. So how does it work? Normally, you would probably set some flags and check them every time an event appears, whether something is correct or not. And in this case, we'll work with signals. So each field will contain a signal that will emit values typed into that. So every time I type a new value to this field, it will be propagated by a signal. Okay, but I do not need text values exactly to say whether the form is correct or not. I just need a Boolean values saying true or false. So let's map it and let's say, okay, if there are more than 2 characters, then basically propagate true. If not, then false, and that's what I need. In case of a surname, it works exactly the same. In case of a mail, you basically go to Stack Overflow and you copy that, I guess. And then you test it. And now we have 3 signals that will propagate true or false values for you. And this is still not enough. We only need 1 value indicating whether the whole form is fine for you. So you have to work with all those signals. You call combine latest, and now you have this form data signal. And it will propagate values for each of those signals. And now you say, okay, map them to 1 value that will be true if each of those values is true. And now what we get is valid form signal that will emit true or false, whether the field is correct, whether the form is correct or not. And what's left for us is to observe this created signal and say, okay, update the button with a given state for that. Or we can even bind it to a property so others can use it somewhere else. And that's basically how you work with functional reactive programming frameworks. In this case, this is Reactive Cocoa, ReactiveSwift. And for me, it's really changed the way I build up mobile applications right now. I think that it works extremely well with MVVM pattern. And I think that this is the way that I would build my applications for some time right now. And basically, set completed. So thank you very much.